Lesson 8.8, exponential growth and decay. We deal with this stuff on a daily. Okay, so let's say you're calculating a population of deer, or you're a wildlife biologist and you have a population of deer. And you go out there, you tag them, you count them, yada yada. What's the one thing that's happening with deer right now in Montana? The chronic wasting disease. So there's a decay factor. And what the biologists have done, if they have calculated the decay factor, so then you can determine how many deer you would have or how many deer are projected to have the chronic wasting disease. They also use it to count to see how many tickets or how many season pass or season hunting tickets go out. The license, that's what I'm trying to say. See how many of those go out. Okay? They do it for bears, wolves, elk. That's why when you have to fill in the form in the spring, you're not guaranteed a tag. So, exponential growth and decay, there's your formula. Y equals A times B to the X. A is your initial value. That's how many you initially populated or how many you initially counted. If your B is bigger than 1, or if it's greater than 1, you have a growth factor. If your B is less than 1, it's a decay. So let's say we're dealing with bunnies. Say you start off with 2 bunnies. Okay, 2 bunnies. So, what happens with bunnies? They populate rapidly. Okay, so if I'm writing the equation, let's say their growth rate, their growth factor is 73%. Okay? Bunnies are growing at 73%. So if I want to set up my equation, y equals my initial amount of bunnies times 73%. How do I convert that to decimal? 0.73. Now, when it's a growth, you always add 1 to it. When it is a growth, you always add 1 to it. So this right here would be the formula that you would use. X would be your number of days later. Let's say we have a decay. Let's say we're looking at something that's happening right now, COVID. Let's say you've got 20 people, 20 initial people. They're saying the decay factor for COVID is like a 0.2%. So we're at 2%. Convert that, be 0.02, right? Okay. But now, with growth, we added 1 to it. With the decay factor, what do you think we're going to take away from it? 1. What's 1 minus 0.02? 0.98. 1 minus 0.02 is 0.98 to the X. That would be the COVID formula. 90% decay factor. 98% decay factor, which reduces down to a 2% decay factor. That would be your death rate, yes.
But yet again, people only are dying on people who are really
These are the actual, that's the actual numbers for actual COVID. That's the actual COVID percentage. Exactly. That's why if you're healthy, you're good to go. All right, guys.
X equals days, right?
Yes. Or time, whatever it is. All right, this one here. So if you're given the equation, what is my initial amount? 368 is my initial value. Is that a growth or a decay? Growth. A growth of what?
70.75.
Or 75%. Good. Take that one away. Okay? This right here. What is my initial value? Is that a growth or a decay? What's my decay factor? Take 1 away. So it'd be what? What's 1 minus 35? 100 minus 35.
Negative.
What's 100 minus 35? 65. My decay would be a 65% decay.
You said 3,500 is 100.
100 minus 35 is what I meant. Some of these you're just going to be finding the growth and the decay. This right here. Let's say you want to put $3,500 into an account. And it is compounded quarterly. How many times a year is it compounded then? 4 times. Okay? Quarterly is 4 times. I want to find how much money I'm going to have after 5 years. So your equation, y equals, what's your initial value? Okay, is that a growth or a decay? Better be a growth, okay? So if I have 2.6%, how would I write that as a decimal?
2.60.
0.026, right? Move that over twice. Okay, because it is a growth, what do I have to add to it?
1.
So I would do 1.026. Quarterly, I'm dividing it by 4 because it's 4 times a year. And then I'm going to raise it to the x. Well, what's x going to be in this situation? So if I want to find this, it'd be 3,500 times 1.026 over 4 raised to the 5th. Make sure you're doing that in your calculator first and then multiplying it to the 3,500. Okay? Which we get, what do we get? 1.026 divided by 4 raised to the 5th times 3,500. So what, 3,886 in some odd sense. Oh, 1, 2. Okay? So that means you've only gained how much money in 5 years? About $300.
$86. And 2 cents.
Okay?
Is that it?